Yes, I'm welcome to give or happy to give a summary of our service, the region reanalysis for Europe. Yeah, I'm giving this presentation, of course, on behalf of the entire service team. See here on the pictures already some of the members that are working in the service. I can say that we are in total approximately 20 people who are involved in this project, and I give you already some overview details. So we are belonging to the C3S service families, as mentioned by Samantha. The service is running in total over 4 years. So we started in September 2017. So we're now into our last year. And it's not SMHI only who are providing or producing the data set. We have our partners. Without them, it would not be possible to deliver the service. So we have partners at Meteo France and at the Norwegian Meteorological Institute who are helping us. So let's jump directly into it. So what's the service about? Of course, it's about data. It's about long series of freely available reanalysis data. And there are two different data sets. So there is the UERRA data set starting in 1961 and continuing until 2019 with a horizontal resolution of 11 kilometer and then 5.5 kilometer for the surface analysis. And then there's another data set, the next generation, under production in the moment, and this will start in 1984. But I think the service is not only about data, it's also about the users out there and to support and guide them. I think that's an important part of our service, and that's actually why we're here today, and having this workshop and exchanging ideas, perhaps also for the future. I have to mention the Europroject, which was essential also for this service, since we are using a system which was developed in the UERRA project, and UERRA stands for Uncertainties in Ensembles of Regional Reanalysis. Yeah, please have a look on the website if you want to learn more about this project, which actually ended already in 2017. Back to our service. So we started in September 2017. As I mentioned earlier, we had a system right from the beginning. And with this system, we started to produce data more or less from the beginning in close to real time. And that's a little bit different, perhaps, than what ERRA 5 is producing in real time. So we produce data with a delay of 3 to 4 months behind real time. And that data set ends in July 2019. And the reason for that is that that was the end of ERRA interim. And ERRA interim is used as lateral boundary conditions. So without lateral boundary conditions, it's not possible to continue with this system. And in the meantime, we started also to develop the new system, which then should take over production later. But I would first like to focus on the UERRA system and continue a little bit with that one. Some more details about the components of the UERRA system. So I mentioned already that we used the global reanalysis as lateral boundary conditions, and then we have several components in UERRA. So there's the 3D upper air analysis in the so-called UERRA harmony system. And then we're using information from this reanalysis as background fields to surface reanalysis. And the system is called Misgarn surface. And there will be a talk about Misgarn surface later today. Perhaps some details for those who know about it, but I'm not going into details here. So we're using 3D VAR assimilation in UERRA, and there are only conventional observations. So, for example, no satellite data. We're running 4 cycles a day. I will explain this a little bit more later. And I think resolution was already mentioned a couple of times. So the domain and the data, of course, it's the regional reanalysis for Europe. So we cover entire Europe and actually also a little bit beyond. If you consider the most eastern part of Europe, there perhaps we're missing something which you call Europe. But there's the northern Africa is also included, and larger, or some parts of the North Atlantic, even including Greenland, for example, the southern part. And there are a lot of parameters available for the surface and on different levels, so on pressure levels, height levels, model levels. If you're interested in soil levels, you should definitely go to the Mestan Surfix system. Height levels, perhaps I should emphasize, that's something which was produced, set up under the UERRA project with special focus on wind industry, for example. So there are height levels. We have 11 height levels between 15 and 500 meters with 7 parameters. Little bit about the time resolution that we provide. I will start with the figure up here to the upper left. To explain a little bit again that we have 4 analyses per day. That's what I meant when I say that we are running with 4 cycles. So what we actually do in 3D VARs, we use observations to analyze the best state 4 times a day at 0, 6, 12, and 18 UTC. And from this state, we run then the forecast model, save the data hourly, and then we get a new state from the forecast model after 6 hours. And then we simulate again observations, pushing back the model state towards the truth, the observed truth. And then we have a new analysis. And from that, we continue with the next 6-hour analysis and so on. So we continue through our time from 1961 until today. And if you mix the analysis time steps with the shorter forecasts, you can actually get, as indicated in this sketch, you can actually get data for every hour from 1961 until 2019 with our hourly resolution 11 kilometers for entire Europe. But then I'm not going to talk more about data anymore. The data is available in the CDS, and there will be a talk about it later in this session, the last presentation. So, but let's come to the CERRA system. So CERRA is Copernicus European Regional Reanalysis. That's the original time plan, but things are not always working out as it's supposed to be. So sometimes things take longer than expected. So we didn't start the production last year as foreseen, but we started only at the beginning of this year. In February, March, the production with the new system really started. There are some new components to it. We're now having an ensemble system with 10 members running at 11 kilometer resolution. We're going to hear more about this in a talk in the next session. I mentioned already CERRA Land, that's the successor of Mestan Surfix at 5.5 kilometer resolution, and we're going to start this data set in 1984. Some highlights about the CERRA system. Still the same domain as before, but as I mentioned, with higher resolution, you can see with higher resolution, of course, we're adding more information into the system. Here's an example of topography comparison from ERA 5, from the global model to the UERRA harmony system at 11 kilometer, and then the CERRA system 5.5 kilometer. You see how you add with higher resolution more details. So in the mountainous regions, you get clearer the structures of the valleys, you get a clearer coastline, and so on. What else is important to know? So now we are doing 8 cycles a day, which means we have 8 analyses per day, every 3 hours. We switch to ERA 5 as lateral boundary conditions. That's improving the quality also, definitely. We see clear impact. We're using now also remote sensing data, so satellite data, and additional local observations. And yeah, CERRA EDA and CERRA Land, we will hear more about this later. I would also like to mention that there are also now additional output parameters, and that's really an outcome of interactions with the users until the end of 2019. So we included some new parameters as turbulent kinetic energy, for example, that was not available before, but that was a user wish and is now available for, or will be available for CERRA data. What's the status today, or last week actually? So as I mentioned, the production started and it's going on. We produced so far 15% of the data. So it's quite a challenge actually, but we're still aiming to produce the data until late summer 2021. You see that the production is split up into 6 different streams covering different periods of the year. The light colors are actually the spin-up periods. So each stream has a spin-up period of 1 year, so that the model comes really in balance, especially in the soil layers, avoiding any spin-up effect. And yeah, I would also like to mention that hopefully there will be data available, test data available before summer 2021. Last slide for me here is then user support. I mentioned it. I think it's important. I can really recommend to read the user guide if you're using our data. Here we mention also issues with the data. So not any data set has some issues. So please read the documentation which is available. You can go to the homepage. We have actually also examples on how to download data on the Git server. We have published some lessons in Copernicus ULS, so Copernicus User Learning Services, and there we have some lessons about our data. We're organizing workshops as today, and at any time, please send also questions to Copernicus support if you have questions. And with that, I'm done and stop here.